Hello, I'm Mr. McBrien. This is Robotics Team Certification Video 1, Basic Circuits Information. So today, what I'd like to do is introduce some definitions around electricity and talk a bit about a key relationship for our purposes, Ohm's Law. So it's interesting that electricity is in fact kind of hard to define. We can define static electricity as an excess of charge on an object. And what's interesting about static electricity is this form of electricity, which doesn't move and is measured in coulombs, which coulombs are just a measure proportional to the number of to the charge on protons. What's interesting about static electricity is generally it's more of a problem than anything else. What we're really interested in, typically for our devices in robotics, we're interested in moving electricity, current. Current is actually defined as the speed at which electricity moves, and we measure it in amperes, or sometimes we'll call them amps, and that's just a coulomb per second. Now, we'll represent current, since we can't see electrons moving, we'll represent current as an arrow that goes from positive to negative in our circuits. We need to get through some of the basic components of circuits, so we'll start with the thing that makes current move through a circuit, and that's a potential difference. So if we have a battery or we have a power supply, it'll push current around a circuit, and the force or the push involved, we call it potential difference, or sometimes we'll just call it a potential. So the units of potential are volts, and this term has become so prevalent that we actually will often say, instead of saying we apply a potential, we'll say we're applying a voltage. And the symbol, we'll come across symbols a lot in the coming days. The symbol for the battery is just this, representing a series of cells. Now, one note about the kind of electricity we'll use in our projects. All of our projects use a fairly low direct current voltage. The voltage that comes out of our outlets in our house, we would generally characterize that as medium voltage, and it's alternating current. Alternating current is not useful for projects in robotics. You should never connect your projects that you build directly to a power outlet. Okay, some more definitions then. Any working circuit resists the flow of electricity. It'll slow down the flow of electrons. And that resistance can be based on just the type of material, or it can be because a component in the circuit, something like a motor, does work. Resistance, we measure this in ohms, and the symbol for it is a little horseshoe thing, the Greek letter omega. The symbol for the resistor component in a circuit looks like the little zigzag shown on the screen. Okay, I just alluded to short circuits. Short circuits are one of the major risks in robotics in general, and in robotics specifically, in circuits in general. Whenever we have a circuit that doesn't have a load, in other words, no work is being done by the electricity, current then will flow unrestricted. It won't be slowed down at all. And this really isn't a good thing. Some reasons why. Virtually any component you can name has a maximum current rating that can handle. And if you exceed that, you'll burn out that component, either destroying the component, causing a fire, or both. But also, batteries have a limitation to the current that they can generate. without the side effect of heat that comes from them generating electrons, without that heat causing serious problems. So we can melt batteries, or we can even explode them in a worst case scenario. Also, our wires have a maximum current rating as well, and they can heat up and catch fire if we run too much current through them. So this was an example of a short circuit. Someone shorted across the leads of a battery, and it caused a fire and actually burned the house down. We don't want to do this, so we'll work hard to try to avoid short circuits when we build our devices in robotics class. And without a doubt, you need to be very sure that you do not connect the positive and negative terminals of a battery with any conductive material like wire or any kind of metal. All right. So, moving on to a little bit of mathematics. Ohm determined that there was a very simple relationship between current, potential, and resistance. What he found was that the current was equal to the potential divided by the resistance. In other words, the current goes up when the voltage goes up, and the current goes down when the resistance goes up. And that kind of makes sense when you think about it. So we can apply Ohm's law to simple problems or complex problems associated with circuits. So here's an illustration. We can take a proposed circuit that we're thinking about using, and we can determine the current through it before we build it and make sure that the current will be appropriate. So the question is, what's the current in a circuit that has a 200 ohm resistor and a 9 volt potential? And we can just apply the guess process, which you may have seen before, to this problem. We state our givens. The potential is 9 volts. The resistance is 200 ohms. We know that our unknown is current. And then we can write our equation. Ohm's law states that the current is equal to the voltage divided by the resistance. And then we simply substitute in and get a number of 0.045 amperes. Similarly, we can go and determine the voltage that we need in order to get a target current. So, if we have a 1,000 ohm resistance for our device, and we have a target current of 0.02 amps, we can figure out what potential we would require. So it looks something like this. What voltage is required to get 0.02 amps with a 1,000 ohm resistor? And we can do the same guess process, stating our givens, stating the unknown, and when we put Ohm's law down, we have to recognize that it's not in the right form. And so, of course, we can do our trick of saying in order to get voltage on its own, we have to multiply both sides by resistance. So while current is equal to voltage divided by resistance, the potential, or the voltage, is equal to the current times the resistance. And then we can go ahead and substitute in and see that we need a potential of 20 volts to get a current of 0.02 amps through our device. And in a similar fashion, we can go ahead and calculate resistance as well. If we have a target current, and we know we're going to use a 12 volt battery, we can calculate the resistance required and see what kind of a resistor we need. And this problem takes exactly the same form, except for we need to convert Ohm's law into isolating the resistance. So R equals V over I, substitute in, and we can see that we need a 120 ohm resistor in order to get 0.1 amps through our device. So to summarize, potential is the force that pushes electrons through the circuit, and we measure it in volts. Current is the speed of movement of electrons around the circuit, measured in amps or amperes. And the resistance of electrons to movement through the current is fittingly called resistance, measured in ohms. And Ohm's law gives us a very productive relationship between current, resistance, and potential. V equals IR, or current equals potential divided by resistance. Now, for your homework, please complete the Ohm's Law worksheet on Classroom and go ahead and complete the quiz. This should give you good preparation for our process for tomorrow's work. Thank you very much, and have a good day.